Hello everyone, welcome back for our second session, I believe, here. ACT Math. So, here we go. We've seen this slide before, but just a reminder for you guys what's going to be on the exam. We have different categories of questions that we'll see on the exam. We've got pre-algebra, elementary algebra, intermediate algebra, coordinate geometry, plane geometry, and trigonometry. You can figure to see about 20 questions for pre-algebra, elementary algebra, 20 questions for intermediate algebra, coordinate geometry, and roughly about 20 questions for plane geometry and trigonometry. There will be more of the easier topics on the exam when you get ready to take it than there will be on the harder subjects like trigonometry. You could probably only expect to see a few of those problems. So we're going to review a little bit from what we talked about last time. We did pre-algebra. So on the exam that I sent to you guys, the practice exam, there are these questions that I felt were close to the pre-algebra topic. And these different bullet points here tell us some of the important things that we need to know in order to be able to solve some of these problems. Once again, if you guys have looked over the practice exam that I've sent you and you guys have questions, please send those to me or bring them to our next session so that we can discuss them and hopefully improve on our skills for some of these things, because these are the points you're going to want to get. These are the so-called easy questions, and these are the points that you're going to want to hopefully nail down so that you can score well on the ACT. I have a few practice problems I'd like to go over with you. Just a reminder on some of these basic operations for whole numbers. So we're going to subtract some fractions, actually, so we can try and remember our rules for fractions. On our last slide, I told you we had different rules for multiplying, dividing, adding, or subtracting. So we're going to do one of those to warm up. We're going to do a probability problem for a warm-up, and I'll give you a chance to take a look at that and work it out for yourself for in a moment. And then we also have a couple of proportion problems that I think would be useful to do to get some good practice in being able to solve proportions. So, yes, we'll move on to our first warm-up problem. We are going to subtract fractions. So, here's this. Can you see that?
I can see that.
Perfect.
They can see that.
Perfect.
But remember, they can't see you.
Yes, I left my marker over here.
Great.
So here we go. We are going to, what's a good one? I don't know. I'm going to have to make one up. I don't like any of those. So we're going to do 3 and 4/5 minus 1 and let's do 5/7. Brutally hard problem. So hopefully you guys all remember that when I subtract or add fractions, the key here is that I must find a common denominator, right? So, oops. I'm supposed to give them a second to try and solve this, but
That's okay. They can take a second.
yeah.
The other thing is to just a reminder that when you're writing, the microphone's here, so be sure that you're kind of turned a little bit so they can hear you.
Gotcha. All right.
That gave them enough time to write it.
Perfect. Give you a moment to try and ponder this one for a second, and then I will show you how I go about it. So here we go. All right, so rule number 1, when I'm adding or subtracting fractions and I look at this guy and I notice right off the bat the minus symbol, I don't even care about the numbers yet. I want to know what rule I'm going to use. And I'm going to use the adding and subtracting rules, which requires a common denominator. So the first thing I'm going to do is find a common denominator. And I'm actually going to steal this guy and multiply him top and bottom over here. And I'm going to steal that guy and multiply him top and bottom on the other side. So this is going to lead to a brand new problem. So 3 4/5 is equal to 3 still. 4 times 7 is 28 over 35. And this 1 5/7 is equal to 1. And 25 35ths. So I have a new problem. Our new problem looks like this. 3 28 35ths minus 1 25 35ths. Now that I have a common denominator, I can actually do the math on this problem. I can do the whole number part. So 3 minus 1 is equal to 2. And I can do the fractional part. 28 minus 25 happens to be 3 out of the 35. So 3 4/5 minus 1 5/7 is equal to 2 3 35ths. This form of this number is called a mixed number. And I can change that into a full fraction if I have to. This problem is done, by the way, but depending on what you are trying to do with your fractions or mixed numbers, you may want to have it in a different form. So you could have the decimal form, obviously. You could find the decimal of 3 35ths, and that's easiestly done on a calculator. So I will show you here. I simply type in my fraction, 3 divided by 35, and I get this number here. So here's its decimal form. And the last thing that I can show you is to change mixed numbers into improper fractions, which can be done by multiplying this way and adding this way, and it's over our denominator already. 35 times 2 is 70, plus 3 is 73. And there we've solved that problem. 3 4/5 minus 1 5/7 is 2 3/5. And to show you, you can do these things on your calculator, but you have to type your fractions in very carefully. So I have 3 plus 4/5 and that's one thing, minus 1 5/7, and of course There's our number right there. So your calculator will do these things for you. A neat trick on your calculator as well is this button right here. This math button brings up a bunch of different functions. And I do feel that this will be useful on the ACT. Your calculator can solve lots of problems for you, but you have to be the one who is correctly inputting the information into your calculator. So I want you to notice the way that I typed in these numbers. I did the whole number part plus the fractional part minus the whole number part plus the other fractional part to get this answer. And if I want the improper fraction, I can hit math. And this screen says here, convert to fraction, number 1. So I hit that. I've got my answer, convert to fraction. And I hit that. And of course, I get the 73/35 that you see here. So your calculator will do things for you in decimals. It will also do things for you in improper or proper fraction form. Your calculator will always give you the lowest term for fractions. So if you're having trouble, per se, reducing fractions, then your calculator will do that for you as well. Take a look here. Let's say I am not sure what 10/20 reduces to. Hopefully we all know that 10/20 is 0.5 or 1/2. We divide here by 10, and that's 1. We divide here by 10, and that's 2. But your calculator will also do this for you. So if I type in 10 divided by 20, I hit enter, my calculator calculates 0.5, which is good because that's a half, in decimal form. But say my ACT multiple choice answers are all in fractions, reduced fractions, and I need to find that out, I can hit, once again, hit math right here under the green button. And it brings up this menu of lots of different options, and I want option number 1, convert to fraction. So it's got my answer of 0.5, converting it to a fraction. I hit that, and it tells me 1 divided by 2. So your calculator will simplify problems for you in many, many ways, which is good because we only have 1 minute to answer each one of these questions on this exam. But knowing how to do that on your calculator will be very beneficial for you in the future. Okay. Now is a chance to ask me questions. If anything that I did for this warm-up problem was confusing or didn't make sense, please write those things down in either an email or ask me face-to-face the next time that we meet. Thank you. Our next warm-up problem is going to be on probability. We know that probability is a big portion of the tests, the small amount of descriptive statistics. We need to be able to calculate our chance of winning stuff. Probability was always my favorite because I like to play games and calculate my chances of winning. So, probability is important. So here's our next question. I'll give you a moment to look at it, ponder it, and then I will show you, or you can pause the recording and try and solve it yourself, and then continue to play the playback and see how I go about this problem. So a bag contains 10 black marbles, 20 white marbles, and 5 gray ones. You pick one without looking. So you're reaching randomly into this bag of marbles. Your eyes are closed, and you're picking out one. One. What is the probability that the marble will be white or black? So probability white or black is equal to total of white or black divided by the total number of marbles, which is equal to 10 plus 20 divided by 10 plus 20 plus 5, which is equal to 30 out of 35. And probabilities may or may not be reduced. So you have a 30 out of 35 chance of picking a white or black marble. Or, if you factor out what's common here, 30 divided by 5 is 6. And 35 divided by 5 is 7. So a 6 out of 7 chance of drawing a white or black marble. Using our calculator, I can type in 30 divided by 35 and get this decimal. And I can reduce it, math, fraction, convert to fraction, and I get 6/7, like we said we would. In a decimal form, that's 0.85714, which implies we have an 85.714% chance of drawing a black or white marble. So that's basic probability. Good review. Once again, if you guys have any questions, please email me or shoot them to me through our next session. The last two problems that I have as warm-ups are proportion problems. It's going to be proportions on the ACT exam. Proportions show up in lots of different ways in the real world, and during these exams, they will definitely be on there. So they generally are present themselves as story problems, just like everything. So here we go. I'll give you guys a moment to look at this, pause this, take a look, see if you can set up the proportion, and in a second I will show you how I do it. Okay, a snowstorm dumped 18 inches of snow in a 12-hour period. That seems reasonable. That happens to us here in Montana all the time. So how many inches fell per hour? Well, you could do 18 inches is to 12 hours as how many inches is to 1 hour. So that's our proportion set up. And now all we have to do is solve for our question mark that you see here. And we do that by cross-multiplying the numbers that we have available to us that are across or diagonal from each other and dividing by the one that's extra. So I multiply this way. I get 18 times 1 is 18. And divided by 12 tells me that I got, we'll use our calculator because arithmetic is not fun. This is definitely doable, but 18 divided by 12, it's 1.5. 1.5 inches per 1 hour. So that one has been solved. That one was kind of easy. The reason I chose 2 is because this one happens to be 18 times 1 divided by 12, which you could have just right off the bat divided 18 by 12, and that would have also given you 1.5. But it's important to recognize proportions and to be able to set them up. So that's why I chose this second problem that I'll give you a moment to take a look at. Carol spends 17 hours in 2-week period practicing basketball. How many hours does she practice in 5 weeks? Which seems pertinent because you guys are playing basketball right now. Carol spends 17 hours in 2 weeks. So 17 hours per 2 weeks is equal to how many hours in 5 weeks? Notice this time when the proportion is set up, we're not going to have something easily just quickly divisible. We're going to have to actually do this multiplication here and divide by 2. So we have 17 times 5 divided by 2. And what does that equal? 17 times 5 divided by 2. 42.5. So 42.5 hours of practice in 5 weeks. All right, so that's a quick review. We're going to move on to some other topics and some other little bit harder problems. This is pre-algebra stuff. There's lots of stuff online. There's lots of stuff in probably your books in schools, in your school. There are lots of practice problems out there. So I would get comfortable with some of these concepts. Fractions are a big one. Percents, proportions is a big one. Simple probability. They are definitely going to be on the ACT.
Pause for a minute.
Pause for a moment. Hello everyone, welcome back. We are moving on to the next topic of our ACT math preparation. We're doing elementary algebra, so hopefully we've got some of these pre-algebra concepts nailed down and we're feeling confident about our skills there. Once again, if not, you guys have my email. Please email me questions. Ask your teachers. Ask for help if things are not making sense. I'm going to do a few problems from the actual practice exam that I gave you guys this section this time around. So hopefully you guys have that handy or nearby so you can follow along. And hopefully I go through some of the problems that you may have questions on. So there's quite a few here that fall into the elementary algebra section. And there's going to be other topics that I just want to just make sure you're comfortable with. So we'll do some problems. I also have a slideshow here of some things that I'd like to show you. So we're moving on to elementary algebra. As you can see here, I have properties of exponents and square roots. That's going to be, it's a little bit higher level stuff. But these rules that you see behind me are all useful rules. I wouldn't, of course, it'd be nice if we could memorize all of these rules behind me and make sense of them, just how they are, but we should just run through a couple of them so that you can see how they work. But memorizing is not necessarily going to be the most beneficial thing. Understanding is more important. So take a look at these rules right fast. Let's see if I have them. Oh, I think I do. Can we pause for a second? So we're going to talk about some of these rules that you see behind me, mostly these properties of exponents, but the properties of square roots are very similar. So we're going to do a practice problem here with a to the n times a to the n, and how that is equal to a to the n plus m. So I'm going to switch to the other camera and enter. Did I do it? There it is. Perfect. So I wrote down these rules that you just saw, some of them. I got a to the 1, so any number to the first power, and all numbers are to a power, right? There's 1 is an implied power. So if I have any number, for example, the number 3, well, the number 3 can be represented like that. It can be represented as 3.0. It can also be represented as 3.0 to the first power. So depending on what you're trying to calculate, you may need to recognize what power is on a number. If it's not shown, then it's automatically 1. So a, being any number to the first power, is just that number. That's what that is saying. Notice this rule here, a to the 0 is equal to 1. So I want to show you in my calculator so that you have a little bit of proof besides my word for it. But any number that I take to the 0 power, and my favorite number is 11, so I'll take it to the 0 power. That's what this key right here is. We call it the caret. It's the to the button. You'll also find it on computers. It's Shift 6. Right above the 6 on your keyboard, you'll see this same symbol. That's the to the symbol. So this is how we take things to different powers. Anyways, anything to the 0 power is 1. 11 to the 0 power is 1. How about another number? 7 to the 0 power. 1. Still 1. How about 100 to the 0 power? There it is. It's 1. So that's the rule. Anything to the 0 power is 1. Anything to the first power is itself. Anything to the second power is its times itself 2 times. Third power times itself 3 times. Fourth power times itself 4 times. And so on and so on and so on. If we need an example of that, we can do 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 2 times 2, which is 4. 2 cubed is 2 times 2 times 2, which is 8. And so on and so forth. So this is the idea behind powers. And then powers obviously have the properties that they come with that I'm showing you here. We'll work on a problem. Say we have 3 to the 6th times 3 to the 4th. We could very easily calculate that in our calculators. 3 to the 6th is 729 times 3 to the 4th, which is 81. We multiply those numbers together. We get 59,049. And that's the hard way. That was the hard way of doing it. It wasn't too difficult. But the rule up here, if we notice, says that if I have some number to some power m times that same number to a different power n, then I can take that number to the power of m plus n. So as you can see here, I have 3 as my a, 6 as my m, 3 as my a again, and 4 as my n. So this problem then becomes 3 to the 6 plus 4, which is equal to 3 to the 10th. And in my calculator, I type that in, and sure enough, 59,049. So if you wanted to learn some ACT tricks to help you move along faster, not that this took us a long time and our calculators could solve it this way, but these rules, these properties of exponents up here, And this isn't all of them. The slide that I had showed you back at camera 1, that has most of them. This I just drew. These are your basic ones that you're going to want to remember. A to the m, or a to the m times a to the n is equal to a to the m plus n. Similar, if we divide here, if we're dividing these numbers, we're just subtracting the exponents. So this could potentially save you time on the exam. And they are fun problems. I would suggest practicing them so that you can get used to them. It's important to understand what it means to be to a power and what that represents. If you understand what something to some power means, it's easier to solve for. For example, say I have a problem where I have 2a squared to the 4th power in parentheses. Well, this is equal to 2a squared times 2a squared times 2a squared times 2a squared 4 times. So that cleared the parentheses. And now I can follow the same rules that I had up here. I multiply all my 2's. 2 times 2 is 4. Times 2 again is 8. Times 2 again is 16. And I count how many a's squared, or how many a's I have. I have 2 here, 2 here, 2 here, and 2 here. So 2, 4, 6, 8. A to the 8th. Basically, this guy was being distributed to both of these. We multiplied 4 times 2 and got 8. And we took 2 to the 4th power to get 16. So these are different properties of exponents. There's lots of different properties. You can find them online. If you literally just type in properties of exponents, a whole sheet will come up and it'll look a lot like this top portion here. And if you can make sense of those, it'll save you a lot of time on the ACT. More importantly, though, understanding what it means to be taken to the power of something, knowing that it's repeated multiplication. So that was a good review of that. Let's go back to our other slide, or our other camera. Let's see if I can do this. Camera 1, like Wayne's World. Camera 1, camera 2. And then we have to hit the options button.
Yep.
People and content. Here we go.
Go.
Hi. I'm back. Perfect. So that was this side. This side right here. That was a good chunk of the things you'll need to know for properties of exponents. On the other side, we have properties of square roots.
Come the other way. The other way. Come towards me. Now point with the other hand. There you go.
There it is. Properties of square roots. Notice on this side, there is no adding or subtraction symbols at all. You cannot break up a square root over the addition or subtraction symbols, but as you can see on this one here, the square root of some fraction is the square root of the numerator divided by the square root of the denominator. Similarly, if we're multiplying two numbers together, we can take the square root of one and multiply it to the square root of the other, and that's the same thing as the square root of the whole thing. No addition, no subtraction. This rule only works with multiplication and division. But it'll be able to simplify your life if you can make sense of these rules. And we may have some practice in our practice problems with these. Maybe. Not sure. Okay. Next slide. Next thing. Evaluation of algebraic expressions. So when we are reading algebraic sentences, we read them like a sentence from left to right. These things should just flow smoothly. It shouldn't be a very hard thing to read.
Go that way. Now point with your other hand. There you go. You're getting
Reading algebraic expressions like a sentence, from left to right. We have different associative, commutative, distributive laws that you should all be familiar with. Associative laws are that the quantity A plus B inside parentheses plus C is equal to the quantity A plus B plus C in parentheses. So if you look up either associative, commutative, or distributive laws, you will see examples on the Google machine of all of those things. Commutativity is the simple fact that we have commutativity amongst addition and multiplication. So it's like saying 3 plus 5 is equal to 5 plus 3. But 3 plus 5 is not equal to, or 3 minus 5 is not equal to 5 minus 3. So there is a reason we have these technical definitions, but you guys should be used to at least using these things when it comes time to take the ACT. We need to get comfortable manipulating equations in order to isolate variables, moving things from the left-hand side of an equal sign to the right-hand side of an equal sign, and back and forth. So these are things that you should be comfortable with, and if you're not, ask for help. Let me know via email. We can practice some of these things, and I can find you specific practice if that is something that you're interested in. And then, of course, when you're evaluating algebraic expressions, they're substituting actual numerical values for variables. We have a good practice problem on your exam, the practice exam that I gave you. Question number 4. We're going to start with that guy. So we'll move to camera number 2. Camera. Perfect. I just made duck face. Oh, weird. So here we are. Problem number 4. I highlighted it here. It says, can we all read that? Let's see if we zoom in a little bit. Maybe the other button. Aha. There it is. Given f is equal to cd cubed, f equals 450, and d equals 10, what is c? Well, that is a good question. And I answer. So, f is equal to cd cubed. And it says here that f is equal to 450, so I'll just replace f with 450. And it says that d is equal to 10, so I will replace d with 10. And now I'm left with just one variable in this problem. Sorry about that. F is equal to cd cubed, f is equal to 450, d is equal to 10. So now I've replaced my f and my d with actual numerical values. From here I will use my calculator to help solve. 10 to the third power is 1,000. 10 to the third is 1,000. So I'll rewrite this as 450 is equal to c times 1,000. Divide out the 1,000 on the right hand side. And what you do to one side, you have to do the other. It's the first rule of algebra. C times 1,000 divided by 1,000 just leaves me with C on the right hand side. And 450 divided by 1,000 is a horrible number, like 0.45. So there it is. There is us in action, actually plugging in values. F is the answer here, 0.45. Here's an example of us actually taking numerical values and subbing them in for variables so that we can solve for other variables. We're taking what is known and finding what is unknown. Zoom out so you guys can see that a little bit more clearly. This is number 4. All right. We'll move on to number 23. 23 is a problem. Using our distributive law. So let's zoom in on 23 here for a brief minute. Oh boy. Will I ever get it in there? Which of the following expressions is equivalent to this out of these? So we have 1/2 y squared times 6x plus 2y plus 12x minus 2y. So we have to simplify this thing and find out what equation is equivalent to it. So the first thing I'm going to do in this problem is I'm going to look at that and I'm going to combine like terms. By like terms, I mean what things are like each other, just like each other. When I look at this, I see that 6x and 12x look just like each other, and 2y and negative 2y look just like each other. So I am going to solve what's in the parentheses first. I'm going to combine like terms. Combine like terms. So I still have this out here. 6 plus 12 right here is 18 x's. And a plus 2y and a minus 2y is 0. I'm done. I'm done with combining those like terms. Now I'm going to multiply these two terms together. And when you multiply fractions, it's top to top and bottom to bottom. Numerator to numerator, denominator to denominator. So I get 18 times 1. So I have 18 over 2 xy squared. And 18 divided by 2 happens to be 9. So 9xy squared is my simplified version. And if we look at our choices, and if you look at choice A here, we have 9xy squared. So we could have, right off the bat, taken all of this and distributed it piece by piece to all of these. But instead, I combined my like terms in my parentheses. If you did the distribution, it would have come out the same way. I collected my like terms to solve for this portion first, and then combined my 18 and my 1/2. And my x's and y's are separate from each other after that. There's nothing I can do with those. So 1/2 y squared times 6x plus 2y plus 12x minus 2y simplifies down to 9xy squared. If you guys have questions or concerns or comments, please let me know. and we can do more practice. There is a tricky problem, number 51. Encompasses a lot of these ideas. But it falls under the category of manipulating equations in order to isolate variables. So if you look at problem number 51, says that we have x over y is equal to 5 halves, and y over z is equal to 3 halves, and it wants x over z. That's what we're looking for. So here's the problem. And we are going to manipulate these equations until we have x over z. So I solved this problem by solving for y in both equations. Notice there's a y in both of these. So I solved this equation for y. I had multiply this side by y, goes over here, multiply this by y, so I have x is equal to 5 halves times y. And divide out the 5 halves. So now I have y is equal to x over 1 times 2 over 5. So y is equal to 2x over 5. And on this one it's simply canceling out the z's, so I have y is equal to 3z over 2. Now that I have y is equal to this, now that I have y is equal to this, and y is equal to this, I can set these two things equal to each other because they both equal y. So over 5 is equal to 3z over 2. And what I'm trying to get is x over z. So I can multiply this side by 5. I cancel. Side by 5, so I have 2x equals 15z over 2. Divide out the 2. So now I have x is equal to, when you divide fractions, you multiply by the reciprocal. So I still have 15 over 2, but I'm multiplying it by 1 over 2. So I have 15z over 4. Divide by z, I get xz is equal to 15 over 4. This is what I was looking for, was xz. This is what I have found down on blue. And I also hope that that's a choice in my multiple choice answers here, number 51. Zoom in. And if you look and see, xz 15.4 is E. So our answer is E. All right. So that's a little bit of the start of intermediate algebra. Can we pause for 1 second? Alright guys, so we just solved some algebraic problems by subbing in variables, by isolating variables. The next thing that we're going to work on is actually setting up an algebraic equation. So using variables to express functional relationships. You can see some of these problems are problems 8 or 9. Those are good story problems that you can set up algebraically. And then of course solving problems using formulas that are already set up for you, where it's just plug in the right stuff in the correct spot, calculate it. So those are the next few problems that we're going to work on. So if you guys would take a look at number 8, we are going to read this story problem and then set up an equation by letting x equal what it is we're trying to figure out. Like letting x equal the unknown. So let's take a look at problem number 8 here. Camera. Number 2. Over here. Looking at problem number 8. The shipping rate for customers of ShipQuick consists of a fee per box and a price per pound for each box. The table below gives the fee and the price per pound for customers' shipping boxes of various weights. Now I want you guys to keep in mind that this problem can be solved just using logic, common sense, and that might even be the quickest way to go about it. So if that's what works for you, I don't want to take that away from you. But I do want to take this opportunity to show you that you can set up this equation, or set up this problem as an equation, and just solve for what it is that you are looking for. So here we have this weight of box in pounds, less than 10, 10 to 25, more than 25. Here's the flat fee, right? A flat fee. No matter what, this is what you're going to be paying, and then after that they weigh it and they tag on some more. So Greg wants ShipQuick to ship one box that weighs 15 pounds. What is the shipping rate for this box? So first off, we got to find out where 15 lies on the number line. Happens to lie between 10 and 25. So we're going to let x equal the pounds of package. And if that's the case, then we know 15 pounds, we're between 10 and 25, so we have a $10 fee plus a 65-cent fee for every pound. So there I've set up an equation. Oops, zoom, zoom, zoom. So looking at this, I let x equal the pounds of the package. I looked at my little table, and I decided 15 was between 10 and 25 pounds. So there's a flat fee of $10 and a 65-cent per pound after that. So this is y equals price. Now I can solve this equation, 10.65, plug in 15 for it. There goes my marker. It's all good. Type this into my calculator, 10 plus 0.65 times 15. Hit enter, and whabamo, there it is. 1975. So, what's his name? Greg is going to be paying $19.75 to have this package delivered. Similarly, we can set up other equations from other story problems. If you consider number 9 here, this is number 8. If you consider number 9, we'll zoom in so you can read it, or you can read it off of your guys' copy of the exam. Well, let's take a look here. A computer chip is 0.32 centimeters thick. It's very, 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 very thin. It's not very thick at all. It's made up of layers of silicon. If the top and bottom layers are each 0.03 centimeters thick, and the inner layers are each 0.02 centimeters thick, how many layers are in there? So the way I think about this guy is I'm going to let X represent the inner layers, because that's how many inner layers are there. That's what I'm looking for. So I'm going to let X equal the inner layers. I'm going to reread the problem because when you do story problems, it's important to at least read it 3 times. The first time you read something, you get an idea. The second time you read something, you gain details. And the third time you read it, you actually understand it. So I would suggest, I know that you guys only have a minute per question on this exam, but I wouldn't even start until you've read it at least twice. So now that I've let X equal the inner layers, I'm going to read this again. A computer chip, 0.32 centimeters thick, is equal, so its total is 0.32 centimeters. It is made up of layers of silicon, the top and bottom. So how many layers? The top and the bottom are 0.02. So top plus the bottom is right there. And each layer, are each 0.03. I'm sorry, 0.03. My bad. That's supposed to be a 3. Let X equal inner layers, 0.32 plus 0.3 plus 0.03. So this is the total. This is the bottom layer. There's the top layer. And then we had a bunch of inner layers. And they are 0.02 centimeters thick. And I don't know how many of them I have. That's what I'm supposed to be solving for. So I can solve this problem, combine like terms. These two are like, so this is 0.06 plus 0.02x minus 0.06 from both sides. That goes away. 0.32 minus 26 is equal, or I'm sorry, 0.26 is equal to 0.02x. Divide by 0.02 on both sides. And now x is equal to 13. And then, of course, we hope and pray that 13 is a choice. And there it is. A, 13. X equals 13. So there it is. That's how I set up an equation. Let me zoom out a little bit. I let X equal the inner layers. I read my story 3 times. I figured this was the total. This was the top layer, bottom layer, and these were each of the outside or the inner layers. Once I have that set up, I can do math to this problem or algebra to this problem and solve for X. Solving for the unknown. If you guys have any questions about that or concerns or would like more practice, email me and I will find some for you or help you. Let's go back to camera 1. Scroll over this way. Hit people on content. Alright, here I am. Welcome back, everyone. We made it through. Hopefully this is going okay. This has been a lot of stuff in a short amount of time. My best advice, guys, is the best way to get good at math is by doing math. You do math every day whether you realize you're doing it or not. But sitting down and actually focusing on the processes that you're going through while you're doing these problems will definitely benefit you in the long run. Oops. Alright, you guys have seen me do quite a few algebraic operations and problem solving. This is solving for x. Will pop up on the exam. There will be times where you have to isolate variables, solve for them. There's a little slide here that shows you the process. A lot of these we can guess what the answer is, but guessing is not efficient. It takes up too much time, and we don't have a lot of time on this exam. So understanding, combining like terms, isolating variables, solving for them, those will benefit you. The last thing I have for today is factoring quadratic equations. Quadratic equations will be on the exam. There's just like everything in math, there's adding and its opposite is subtracting. There's multiplying and its opposite is division. Squares and square roots tie each other and then untie each other. These problems like these quadratic problems, anytime you see x squared plus some other x term plus some constant and it's set equal to 0, or even if it's not set equal to 0, you can factor it. So this part right here moves up to this part, and this part over here translates down to this part. So I will show you what I'm talking about here in a moment. But factoring problems are common and most definitely going to be on the exam. So let me see if I can find some that are factorable here in my handy dandy book. Perfect. We're going to move back to the other camera so I can show you guys how to FOIL. Hopefully you guys have heard that before. First, outside, inside, last. And then I will also show you how to factor. So we're going to go from one direction to the other and then back to the other direction. So here we go. Camera 2. Alright, so let's suppose we have x squared plus 8x plus 15. And I am tasked with the wonderful objective of trying to factor this thing into its factorable form. So by factors, I mean it's going to look like something with parentheses being multiplied together. So the first thing I'm going to do is I'm going to look at this 15, and I'm going to write it on the side over here. And I'm going to look at it, and I'm going to think to myself, what are my factors of 15? What are all my positive and negative whole numbers that multiply to 15? Well, there's the easy one, 1 and 15. And the other easy one, which is negative 1 and negative 15, because a negative times a negative is a positive, right? Then there's this one, 3 and 5, and negative 3 and negative 5. And then I'm thinking for 2, no, it's not, it's it's odd, so it's not even. So 2, 3, 4, 5. 5 is in there already, so I'm done. I found my factors. So what am I going to do now with that I have this factor list? I'm going to look and find out which one adds to my middle term. And I notice 3 and 5 add to my middle term, so I hold on to the signs that come with this. This is a positive 3 and a positive side. I'm going to make this x plus 3, x plus 5. Not too difficult at all, was it? It can get a little harder, and we'll talk about that hopefully next time. I'd rather you guys get comfortable with this concept before we move on to the next one. But we need to check our answer and make sure this is right. So the way we check this, to check, we FOIL, which stands for first, outside, inside, last. First, outside, inside, last. We're going to FOIL this thing. We have x plus 3 and x plus 5. And I'm going to do the first terms. What's x times x? Well, that happens to be x squared. That's the definition. Repeated multiplication, right? So that's x squared. So that's first. Then we do the outsides. That's plus 5 times x. Insides, plus 3 times x. And then the last, plus 15. I combine my like terms. My like terms, this is not a like term. You combine like terms over variables and exponents. In this case, these both have an x, and they're both to the first power, so we can combine those. So I get x squared plus 8x plus 15. And if you look back to where we started, at the very beginning, x squared plus 8x plus 15. So x squared plus 8x plus 15 is equal to x plus 3, x plus 5. Factored form. We call this the quadratic form. So there you have it. Factored form, quadratic form. They both equal the same thing. It doesn't matter what you plug in for x. You can plug in any number for x as long as x is all the same number. So if you plug in 4, you got 4 plus 3 times 4 plus 5. That should equal 4 squared plus 8 times 4 plus 15. It will every time. Do we need to see it? Our calculator will not factor for us, unfortunately. So that's a bummer. But let x equal 4. We get 4 squared plus 8 times 4 plus 15, and that equals 63. And 4 plus 3 times 4 plus 5, and that also equals 63. So these two things are equivalent to each other. They're the same. Different form of the same thing. And that may be something that will be useful come test time. So we need to remember FOIL to go this way. First, outside, inside, last. And we need to remember to get the factors of our last term right here and find the ones that add up to our middle term. We'll do that one more time, just for practice. We'll do y squared minus 11y plus 28. So So we'll grab our 28, we'll stick it over here. We'll find our factors. 1 and 28. 2 and 14. I don't think 3. No. 4. 7. 5 no, 6 no, back to 7. So we also have the negatives of all these. -1 and -28, -2 and -14, -4 and -7. Now, which of these 6 factors add up to -11? And I'm going to go with -4 and -7. -7 plus a -4 is -7 minus 4, which equals -11. So here are my factors: x minus 4, x minus 7. Check by foiling. So first is x times x. X squared. Outside is minus 7x. Inside is minus 4x. And the last is -4 times -7 is plus 28. -7 minus 4, x squared minus 11x plus 28. Combine like terms. This is the same as this, except these are supposed to be y's. Forgive me. So used to doing it with x's, but they're supposed to be y's. But they're the same. Notice that they're the same. Alright, that should do it for me today. We've done a lot of stuff. This is foiling. This is factoring quadratic equations. It's one way of solving quadratic equations, so we'll talk next time on how to actually work the formula. But this will be a good tool for you to use on the ACT. I promise. Let me go back to. Oops. What did I do? I didn't hit the arrow. Hit the volume button. Options. Perfect. All right, guys. If you guys have any questions or thoughts or concerns, again, email me. If you'd like more practice, I can find stuff for you. There's lots of practice stuff online.
What's your email address?
It is inspiredclassroomtim@gmail.com. inspiredclassroomtim@gmail.com. So please email me with any questions, concerns that you have. If you'd like more practice, I can help you find that. Also, the internet is a great resource. All the words that I've used on my PowerPoint slide, if you don't understand what those vocabulary words mean, Google them and research them yourself. All this will benefit you when it comes time to take the test. Have a good day. Good luck.